When we look at negative powers, it's important to know that the negative part of the power, the negative part of the index, tells us it's a reciprocal. Reciprocal means whatever you've got to multiply it by to make 1. So for example, if I had 4, what do I have to multiply 4 by to make 1? I have to multiply it by 1/4. If you look, it's 1 over. So I take a half. What do I have to multiply a half by to make 1? I have to multiply it by 2. So the reciprocal is 1 over the number. Now, if we've got a fraction that's not a unit fraction, it's a little bit more complicated. If I've got 2/3, well, how do I turn that into 1? Well, first of all, I need half of it to make 1/3, and then I need 3 of those to make a whole one. So it's like I'm timesing it by half to get 1/3, and then timesing it by 3 to get a whole one, which is the same as, instead of doing both of those, we could just multiply it by 3/2, 3 over 2, which is the opposite of this fraction. So if it is an integer, like 4, we say 1 over. If it is a unit fraction like a half, we use the denominator. And if it is a non-unit fraction like 2/3, we flip the fraction. Okay, so now we've got that, let's have a look at this. All of these bases, 3, x, y, 8 and z, are all integers, they're all whole numbers. So they're all going to be 1 over something. 1 over x, 1 over y, 1 over 8, 1 over z. Okay. And then the power is not acting on the 1, it's acting on, well actually it is acting on the 1, but 1 to the power of 6 is still 6. Sorry, it's still 1. So the power just goes down there. The power of -3 means 1 over to the power 3. The power of -8, 1 over z to the power of 8. So when we have a negative, it means that our answer is the reciprocal of the base, but this power remains the same. Doing the opposite way here, we need to put some negatives in. All of these are unit fractions, 1 over, 1 over, 1 over, which means that the base will be the same, 6, u and v. And the power will be 7. Sorry, that was a phone message coming through on my Bluetooth speaker. There's only 1 u, so it's to the power of 1, and there's 8 v to the power of 8. But they're all fractions. All of these are fractions. So think about the fraction bar as giving a negative to the power, like so. So we've got the base, we've got the power, and then we've got the fraction bar that turns it into a negative. It wants us to rewrite these expressions, then write out a numerical answer. First of all, 4 is an integer, so it's going to be 1 over 4. And the power is 2, so it's going to be 2. So the answer is going to be 1 over 4 squared. What is 4 squared? And 4 squared is 16. So our final answer there would be 1 over 16. Okay, so again, 3 is an integer, so it's going to be 1 over 3 to the power of something, 3 to the power of 4. So our answer is going to be 1 over 3 to the power of 4. That means 3 times 3 is 9, times 3 is 27, times 3 again is 81. I'm not expecting you to remember that off the top of your head, but you will be expected, or you might be expected, to work that out without a calculator in an exam. You won't be asked to do that for any powers other than 1, which is always 1, so that's easy, or 2, which is 2, 4, 8, 16, blah blah blah, or 3. And you probably won't be asked to go above 81 with 3. Or you might be asked with 5 as well, but 5 is another easy one. Okay, second part. Got coefficients in here as well. So what have we got? We've got, first of all, let's have a look at the base. Oh, the base is already there, it's x. easy. So let's have a look at the integer in front first. We've got 8 here, and we've got no coefficient here, so that's just 8 on its own. And now we look at the powers. We've got 3 and 9, and we're multiplying, which means we're going to add the powers. 3 add 9 is 12. Okay, so here, integers, or coefficients, we've got 2 and we've got 9. 2 times 9 is 18. Remember, we multiply the powers. We'll multiply the coefficients because we are multiplying. E is already there for us. Now let's have a look at the powers. We've got 7, and here we've got -4. So it's still the same, we're multiplying, so we add the powers. 7 add -4. Well, that's the same as 7 take away 4, which is 3. Now, the reason we've got brackets around these is so that people don't think that it's, so people can see that all of this is being divided by all of this and not just the power. But it's exactly the same as we would have normally. So let's have a look first of all at the integers. We've got 20 divided by 4. 20 divided by 4 is 5. Now let's have a look at the powers. We've got 7 and the power of 4. Now when we divide, we take away powers. 7 take away 4 is 3. So again, we have a power of 3 there. Sorry, it keeps going in and out of focus. I've got no idea why. Next question, our C's. We've got 15 divided by 5, which means our coefficient here will be 3. Our powers, 2 and 7. Because we're dividing, we take away the powers. 2 subtract 7 is -5. That's our first answer with a negative power. Now this one, we've got it in brackets. So we need to remember what we do. We have to cube or square or whatever, everything in the brackets. So we're going to, first of all, we're going to do 3 squared. What is 3 squared? 3 squared is 9. And what do we do with the power when it's in brackets? When the power is in brackets, we multiply. So that's 4 times 2, 8. And lastly, for this side anyway, we've got, again, it's squared, 2 squared, which is 4. And then we've got 2 the power times 2 the outside power, which is 4. So that's 4 into the power of 4. Moving across to the other side, we've got some fractions. Remember, fractions are just divisions. It's just another way of writing it. And quite frankly, it's 1 line instead of 2, 1 line and 2 dots. So, you know. Also, in my opinion, looks neater, and we don't need those brackets anymore. Always useful. So let's have a look again, first of all, at the coefficient. Look at the top first. Look at the top. Terrible language. Look at the numerator first. 21 times 20. And 21 times 20 is 420. Yep, 420. And then divided by 6. 420 divided by 6. 42 divided by 6 is 7. So 420 divided by 6 must be 70. And then we look at the powers. So again, numerator first. 3 and 11. We're multiplying, so we add the powers. 3 add 11 is 14. And then we think about this 8. Now we're dividing because it's a fraction. So we're going to subtract. So we're going to do 14 subtract 8, which gives me a power of 6. Here we've got brackets and then multiplying. So I might have to do a little bit of working underneath. But again, first thing we'll do is we'll look at the integers. We won't look at anything else until we've done that. So we've got 2 to the power of 5. So we've got 2, 4, 8, 16, 32. And then over here we've got 2 to the power of -1. Now remember what we said? Negative powers are reciprocals. The reciprocal of 2 is 1 over 2. It's 1 over 2 to the power of 1, which is just 2. So it's 32 times a half. What is 32 times a half? 16. Now let's look at the powers. We've got 2 and 5. Powers of 2 and the power of 5. So that's going to give me the power of 10. So I multiply because they're opposite sides of a bracket. Here, I've got 4 and -1. And those, I'm going to multiply those two. 4 times -1 is -4. What am I doing with these? I'm multiplying them, which means I need to add the powers. 10 add -4 gives me 6. Wow, fraction, multiply and brackets. Let's have a look at this one. Again, first of all, I'm going to look at the integers. So I've got 6 times 6 squared. What is 6 squared? We know that, hopefully. Do we? Yes, we do. 6 squared is 36. 6 times 36 is 216. That's actually 6 cubed, so that is one that hopefully you'll remember by the time the exam comes around, or we'll be able to work out quickly. And then the denominator has a 9, so we're going to do 216 divided by 9. I'm not expecting you to do that in your head. 9 into 2 doesn't go. 9 into 21 goes 2. Remainder 3. Did not give myself a second. 4. Okay, 24. That is really terrible, giving myself no working route at all, but never mind. Now let's look at the powers. We've got 4, and we've got a power of 2 that's been squared. So we've got 4, add, because we're timesing, 2 times 2 is 4. Gives me 8. So the power of the numerator is 8. But then the power of the denominator is 2. Which means we're dividing. And if we're dividing, what do we do with the powers? If we're dividing, we subtract the powers. So again here, the power is 6. Look, 6, 6, 6. Obviously, this is the MyMaths of the devil.